the 3 half-lives method for determining half-life. This is a method that can be used when you don't know the half-life of a sample, but you've been able to collect a variety of data about the decay of your sample. For example, let's say you have a radioactive rock, and the only thing you can measure about your radioactive rock is the activity of that rock in counts per minute. These are the little beeps that come out of the radiation monitor. And so over a period of days, you monitor the activity or the radiation coming from the rock. And at day 0, your rock has an activity of 800 counts per minute. And then here's our 3rd day, and our 6th day, and our 9th day, and our 12th day. Knowing that half-life is an exponential style graph, you fit your data to an exponential curve, and now you need to figure out what the half-life is. We know that the half-life is the amount of time it takes for our sample to lose half of its activity. So what we're going to do is use this graph to determine 3 different half-lives and then average them. Now the first half-life is really a pretty obvious one. We're going to go from an activity of 800 counts per minute down to an activity of 400 counts per minute and just figure out how long it took to get there. So at 800 counts per minute we were at day 0. And if we come down to 400 counts per minute, it looks like about 5.7 days is probably how long it took to get that far. So that's our first half-life. Even our second half-life is really a pretty simple one here. The next obvious thing to do is to go from 400 counts per minute down to 200 counts per minute. So that's kind of our second half-life. How long does it take to get from 400 down to 200? The thing is, now we don't need how long it took to get all the way out to 200. We need how long it took to get from 400, which we already decided was 5.7 days, all the way to 200, which looks like we hit 200 at about 11.6-ish or so days. So to find our second half-life, we have to do a little bit of subtraction here. It ended at 200 at 11.6 days, but it started at 400 at 5.7 days. So our second half-life lasts for about 5.9 days. Now the next obvious thing to do would be to go from an activity of 200 down to an activity of 100 to cut it in half again. But if you look at your graph doesn't go down as far as 100. The nice thing about half-life is it doesn't really matter what you decide to choose for your reference points, as long as it's half of what you started with. So maybe for my third half-life, I will make a choice here that I'm going to start at 600 and cut that in half and go down to 300. And you really can choose any starting point you want as long as half that starting point is in fact on your graph. So for my third half-life, I'm just going to make a choice to go from 600 to 300. And like I said, anything would do. You just got to pick a couple, or pick one, and make sure that half of that is on the chart. And now we need to figure out how much time it took to go from 600 counts per minute to 300 counts per minute. So we go back up here to our graph, and at 600 counts per minute, we were about right there. And that looks to be 600, let's call that about 2.4 days. So I'm going to write that down just so I don't forget, 2.4. And at 300 counts per minute, I'm all the way out here. That looks to be about 8.3. So to figure out the half-life, we are going to take the 8.3 days that represented my 300 counts per minute and subtract the 2.4 days that represented the 600 counts per minute. And we come up with a half-life of 5.9 days. And now that you have three half-lives, 5.7, 5.9, and 5.9, we can average these to figure out what the average half-life is going to be. So down here, we'll just take 5.7 plus 5.9 plus 5.9 and average that over the three half-lives. So we'll divide it by 3. And we have an average half-life of about 5.83 days. And that'll work with any sample you have, any half-life graph you've built using an exponential decay curve. You simply pick 3 increments. I chose 800 to 400, 400 to 200, and 600 to 300, making sure that those 3 increments are always representing the sample going from some value down to half that value. Calculate the amount of time it took to do each of those things, and then average them. And that's what we call our method of 3 half-lives.